Hey there, coders. Welcome back to another exciting episode in our Rust programming series. Today, we are diving deep into generics in Rust. Generics are a way to write code that works with multiple types without repeating yourself. Think of them as placeholder for types. You decide the type later at runtime or when calling a function. This makes your code more flexible and avoid duplication. Generics are not just about convenience. Rust ensures they are zero cost abstraction, meaning they are compiled to efficient machine code without any performance penalty. First, let's remove this, also this. First, let's get started with generic function. Here is the main problem arises. You need a function to find largest item in a list. If a list contain integer, you would write function like this fn largest let's say int and here's the code. This function this function works only with the slices of i32 values, means only works with integer. It will find the largest integer and return them back if you want, but with different types like character you did need separate function. If you want to find largest character in an array, here is the function. This is code duplication. The logic is same in both the code, only the type changes. Here generics comes in game. Let's fix this in with generic function. First, import use std cmp partial in capital partial ord. Here is the code. Now, here function fn largest t partial odd list and t. This is t is the placeholder for any type. The t partial odd part means that t must implement the partial odd trait, which allow comparison. Now, in this line of code, just like before, assuming the first item is the largest, and in the loop we will find the largest item. This is not important. Important part is this, that this function takes any type of parameter, means it takes also integer and also character. Let's see how. In the main function, come to main function and let's create one number list with vector, let's say 3450 3450 65. It's okay. And let result is equals to this and print that. Here I am passing the number list which is of i32 type, means integer vector. Let's compile the code, and the largest number is 100. Now let's see, I'm creating one more vector that is of char list, and now I'm passing character value list vector, sorry, and let's print out them. Sorry, let's compile the code and see the output. This function takes integer vector as well as character vector. So the largest is used with both integer and characters, which shows the power of generic function. The type t automatically inferred by Rust based on the type of the element in the list. Now let's see generic structs. Let's explore generic struct. This allow you to define flexible data structure that works with multiple types. Let's see how. Let me remove this. Also remove this code. Now see how. Struct integer point x. Sorry, x is of I 32 and y is of I 32. Let's create one more struct with float point. Float point with f64, f64, and y also f64. These structs represent points in 2D space, but we have two versions, one of the integer and one of the floating point number. This is duplication because the logic of both struct is same, but only the type changes. Let's fix this with generic function. Come to generic function and fix this. Let's remove this part and type one generic function struct. Let's say point, sorry, create one generic function with x as t and also y as t. Here, point t, where t is a placeholder of any type. Now the struct can be used for both integer and float without duplication. Let's see in the main function how it works. Let integer to point this and let float equals to this. Let's say 1.1 and 4.01. Now access them. Access integer, access float. See the output. Integer is 5 and float is 1.1. So this struct takes both integer and float value. Now what if x and y coordinates need to be different types? Here only you have to change y and define one more type. Also here. Now in the main function, you can change the type of y also. 1.1, 1.2, that is, here you can take string as hello div stream, and here 4.01. It's okay. Now run the program. Here t comma u, t and u are placeholder for different types. In point 1, in here x is an integer where y is an floating type, and in point 2 in float x is string whereas y is float type. Let's see how let's see how struct works in generics. Now come to generic enums. Rust's standard library already uses generics in enum like option T and result. You can create your own enum with generics as well. Let's see how. Clear this. So clear this and create enum option with T. Just correct. Give me some minute. Here option T. This enum can hold either a sum T value or none. Let's see in the main part. Let's create one variable of integer, that is option 5. It's okay. And let's create one string, that is not float, string of option hello, not hello world, hello dev stream. It's okay. Now use match if it is integer and if it is string. The code demonstrates handling both some values for integer and string. If it is integer, here prints the value, and if it is string, this prints the value. Let's run the program and see the output. If it is integer, 5, string, that is hello dev string. Now, generic method. You can add method to your generic struct. Let's see how. Let's create one struct, clear this. So clear this also. Let's create one struct with point, let's say t, and it is, and one method that is impl with t, t point with t fnx self, and also write for y fny self dot y. Here impl t block defines method that works for only type t. The impl point block defines a method distance from origin specifically for the point of f32 value. impl point f32 distance from origin and self x dot, yes, it is correct. Let's see in the main function how it works. Let's create one function. Let point equals point, let's say 5 comma 10, yes, it is correct. Println point of x and point of y. Now let's create distance. So what is the error? Distance from, it is of f32, so 5.0 and also 10.0. Now it is correct. See the output. X is 5, y is 10, and distance from origin is this. Here it accepts f32 only. So there is one error in the beginning. Now the conclusion is that we have seen how generics can work with eliminate code duplication, enable flexibility in function structs and enums, provides zero cost abstraction for high performance. That's all for this video. I will see you in next one. Let's keep building with Rust. Thank you.